If we're going to be adding fractions, this is a very difficult and very different game than multiplying or dividing. Adding fractions requires a lot of work. That's why I always do it last whenever I teach. So if we're adding fractions, we'll start off on the easy one. We have 1/2 plus 1/2. Okay? Now, less educated people will maybe say, okay, 1 plus 1 is 2, 2 plus 2 is 4, the answer is 2/4. This makes no sense. The reason why it doesn't make any sense visually, if I have 1/2, I'm adding it to another 1/2, I will get 1/2. Like so. So 1/2, 1 plus 1 is 2. 2 does not get added to itself, just 2/2, because I added one part out of 2 plus another part out of 2. I didn't add the parts and somehow create a bigger number of parts, not how that works. 2/2 simplifies to just being 1, or 1/2. That's why we just add the numerator. So the rule of thumb for adding fractions is that you just add the numerator. Okay? The denominator stays the same. Very simple. Okay? Now, that was an example of adding fractions where the denominators were already the same. It was easy. But what if they don't match? Let's say I did 1/2 plus 3/4. Like I said, I can't add the denominators, not how this works. I also can't add parts out of 2 parts out of 4. This doesn't make much sense. I just can't do it. So what I need to do is make that 1/2 into something that I can actually use. Make it something out of 4. 1/2 is the same thing as saying 2/4. The way I did that, I converted 1/2 to its equivalent fraction with 4 as the denominator. If you need help on finding equivalency, there's a video for that. Now I can add them across. I'm working with the same parts. They're now speaking the same language. So I can do 2 plus 3 is 5, and 4 stays exactly the same, does not move. 5/4 can also alternatively be written as 1 and 1/4. Either one of these answers are fine. This is the mixed number. This is the improper fraction. Now, that's also relatively easy. You only changed one number. What if I have to change both numbers? Let's say I have 1/3 plus 1/4. In no world, in no imagination, will 3 somehow get up to 4 in any way. 4 will never get down to 3. It just doesn't work that way. So both of these numbers must change. I must find the least common multiple of 3 and 4. Once I find the least common multiple, then they can be talking about the same language. They can be speaking the same words. So I asked myself, okay, where will thirds and fourths ultimately meet up? How can I change these around using equivalency to make fractions that are the same number of parts? And the LCM, or least common multiple, of 3 and 4 will be 12. They will ultimately meet up at 12. How did I figure that out? I listed the multiples of 3 in my head. 3, 6, 9, 12, 15. I did the same thing for 4, 4, 8, 12, 16. The first number they have in common is 12. So now these are both written as 12s, but I got to figure out what over 12. Simple equivalency conversion. 3 becomes 12 by multiplying times 4. So I do the same thing to the top. Whatever I did to the bottom, I must do to the top. 1 times 4 is 4. 4 is going to become 12 in some way. 4 times what was 12? That's going to be 3. So 1 times 3 will equal 3. Now when I add these up, 4 plus 3 will be 7. And the bottom number, the denominator, stays exactly the same. That's all it takes to add fractions. It's the hardest skill with fractions thus far. It just takes a little bit of work to get that equivalency and to translate it into numbers that aren't necessarily given to us. The same thing works for subtraction. If, for instance, I wanted to do subtraction instead of addition, the only thing that would change is what I do at the end. I still do my conversion. Now it's just, instead of adding, I'm subtracting. 4 minus 3 is 1. 12 stays the same. The answer will be 1/12 instead. That's all you do for adding and subtracting fractions. That's it. Have a good one.